Okay, welcome back. With these examples, we are going to not start with the equation and find all the characteristics and graph it, but we're going to be given certain characteristics and we have to kind of work backwards to get the equation. And sketching the graph is still going to help. So let's look at this first one. We know that we have an ellipse with the foci being 0 plus or minus 2. The major axis is length 8. So let's get a quick sketch because that could help. Plus or minus 2 for the foci, so it's basically going to be up here 2 and down here 2. Remember, those are not points on the ellipse, but they are a big part of it. The major axis has length 8, while the foci lie along the major axis. So because of that, I know that the center is 0, 0. So that's big. So that's a conclusion I've just made. The center is 0, 0. It's at the origin. And if the major axis has length 8, I have to go up 4 from the center to get one of the vertices, and down 4 to get the other one. Now the vertices really play no role in the equation of my ellipse. But what's important is that we now know that this distance is 4, so that means A is 4. This distance from the focus to the center is C, and C is 2. So because of those two pieces of information, I can now find B. Because remember, B squared was equal to A squared, which is 16, minus C squared, which is 4. So B squared equals 12. Right? So now my equation is simply going to be, well, first of all, let's decide whether it's going to be, well, we don't really have to decide. We know it's going to be one of these types of ellipses. So we could call it vertical if we'd like. So we know the bigger number is going to be beneath the y. So here's x squared and here's y squared. This requires a squared, so there's 16. This requires b squared, so there's 12. We are done. So it really came down to understand the geometry of the ellipse in order to get the equation. Now, if we wanted to find the length of the minor axis, we could do that, but we pretty much have all the important things needed in order to get the equation. Okay, the next one is similar in that we're given some details, so let's start with that. We know that the vertices are plus or minus 4, 0. Again, a quick sketch just to help us. So if I move forward 4 and back 4, I basically have the vertices. That also tells me, remember, that the center is again going to be 0, 0. So that's important. Center, 0, 0. No adjustment there. We also know that the y-intercepts are plus and minus 1. Well, if the y-intercepts are plus and minus 1, because of the symmetry of an ellipse, that's basically the endpoints of your minor axis. So this is a very long, skinny ellipse. Vertices, endpoint are the intercepts. Now, if this was offset, the intercepts would not have that relationship to the center. But what this tells me is that A is going to be 4, B is going to be 1. That's really all I need to write the equation. So I'd get x squared over a squared, 16, plus y squared over b squared, which is still just 1. I don't need to write it, but I can. And it's going to equal 1. Now, if I wanted to find the foci, I could, but that's not really the directions here. We just wanted to write the equation. But I could easily use this relationship between a squared, b squared, and c squared to get c. Once I found c, I could move left and right from the center to get the foci coordinates. One last example. This one's going to involve a little bit more algebra. not as much of the geometry. But basically, I'm going to be given this ellipse in terms of a more general equation. And when we're ready to wrap up everything about conics, I'll give an overview of these types of equations and how we can identify which ones we are going to be seeing. But basically, if I'm telling you that this is an ellipse and you want to define some of the characteristics or even graph it, my goal is to take this form and transform it into something that looks like this, our standard form, our user-friendly form. This is going to involve completing the square a couple times, right? And it is rather complicated. So let's go ahead and get this done. I want to collect the x terms. So I've got 4x squared minus 8x. Then I'm going to collect the y terms. Become plus y squared plus 4y. I'm then going to move this 4 to the other side just because. Now on each of these pairs, I am going to complete the square. In order to complete the square here, I'm going to have to factor out the 4. I'll keep the y squared plus 4y for now. That was one of our requirements in order to complete the square. We need that lead coefficient to be a 1. Then we go through the process of completing the square. I take half that coefficient, which is -1, square it, which is 1, and add it. Over here, I do the same thing. Half this coefficient of 4, square it, and add it. Now we know that we've added something to this left side of the equation, so we must keep a balance. Here, it looks like I've just added 1, but keep in mind that that 1 is affected by this 4. So we've added 4 to this side, so we better add 4 to the other side. Over here, I've also added 4. So now I have this equation, 4 times x minus 1 squared plus y plus 2 squared equals 4. Now if we compare that to our more standard form, we notice that everything is always going to be equal to 1. So I'm going to divide everything by 4. So I get x minus 1 squared. I could put that over 1 if I'd like. Y plus 2 squared over 4 equals 1. Now I have the equation. I'm a happy person. Now I can do all the things that I've done in the previous problems. I can figure out the center. Center is going to be -1, 1, -2. I know what A is. A is 4. How about square root of 4? So it's 2. B is 1. I also know that this is going to be kind of a vertical. If I wanted the vertices, I could find it. So if I start at 1, -2, that's the center. I got to go up 2 and down 2 to get to the vertices. So if I go up 2, I have one vertex here. I go down 2, I have the other vertex down here. Remember, that's always going to be A. So if I move up 2, that's going to be the point 1, 0. The other would be 1, -4. So I have the vertices, I have the center. If I did want to find the foci, I would have to go back and find C. I know the endpoints of the major axis. I could find the endpoints of the minor axis. It's only 1 across. And I could get a nice picture of my ellipse. Now, as I said, if we take a look at all of the different conics, they can all be turned into some type of an equation that looks like this. And based on how these are arranged and what the numbers are, we can know very quickly what type of conic we're going to be facing, but we'll get to that when we summarize everything. Up to this point, we have the circle, the parabola, and the ellipse. We're really going to take the rest of this week just to continue to work through the problem sets from 11.2, 11.3, and even back to section 2.3. By the end of the week, if you have any questions, I would be happy to post a solution video maybe on Friday. And then early next week, I will post a quiz just over these three conics. After that, we'll take a look at the final conic, the hyperbola, and then we'll look at a new way to represent these conics, and that's pretty much it. So stay engaged, keep working, stay in touch. If you have any questions or issues, please let me know, and I'll get back to you as soon as I can. Have a great day. See you soon.